But we should start the next step. Now this is a new topics. Everything is the same except now I have a vector. I call it B perpendicular. It is rotating, right? Rotating, what it means, it has a constant magnitude, but the direction keep pointing through this circle on the XY plane, right? So with that, we will still use this perturbation method. So we still say the total Hamiltonian equals to H0 plus Hi. And of course, H0 is still the same due to the large vertical magnetic field, which is equals to negative mu dot BZ in the Z direction, not head. Right, which is equal to H bar omega L divided by 2 sigma Z, right? I will have many variations, but this is essentially the same Hamiltonian we discussed earlier, because omega L is, what is omega L? It is the Bohr magneton, the mu times the magnetic field, B0, right? You just go back, plug in, you will see that. I actually have this omega L here, right? Where's that? Here, right? Omega L, basically, it is this one. Omega L is just E bar E divided by M times B0. So, not Bohr magneton, it is yeah, it should be equal to this one. But then we need to divide it by H bar. Okay? So we have this already. Now the question is, what is Hi? Right, Hi is nothing. It's just equal to the magnetic moment dot product with the vertical magnetic field. Okay, so what is the vertical magnetic field? It's equal to, wow, I jumped a lot of steps. I mean, it's equal to H bar divided by 2 gamma Bx sigma x minus H bar gamma divided by 2 by sigma y. This is a little bit, a lot of stuff here. Now, that is because what is the magnetic field that we are using? We are using the magnetic field of this. Maybe I should put this first. The magnetic field is equal to the strength times cosine omega 1t plus phi x hat plus sine omega 1t plus phi y hat, right? So maybe I should give you this to you first, right? So the magnetic field has a constant amplitude, B vertical, right? It has a constant amplitude, B vertical. But then it has, the x component is cosine omega 1t. Y component is sine of omega 1t. Basically, it's talking about it's rotating, right? Is this okay? That's a phase diagram. The phasor in the circle. Yeah.
Is it rotating about the y-axis?
No, rotating about the z-axis is on the xy plane. Oh. Yeah, that's why you only have x and y component. Okay, and then the reason that we get this, I guess I skipped some of the step. This mu again is the magnetic moment, right? Remember what is the magnetic moment we just taught earlier? It's just equals to the the E divided by M, negative E divided by M, times the spin, right? The spin moment, which is H bar divided by 2 sigma hat. Yeah? So here, actually, I try to put back the gamma, because the gamma is actually equals to G divided by M times EM. No, that's wrong. G divided by 2 times EM, right? So this is gamma. I keep this as, this whole thing is gamma. Okay? The whole thing is gamma, negative E divided by M. So that's why H bar divided by 2, negative gamma, negative come from here. And then sigma, right, is each of them. You have this X hat times Y hat, right? All this thing. Okay? Now, With this, and then I can further say that HI, I think the HI equals to, right, then I just plug in, because what is Bx? This is Bx. Negative H bar divided by 2 gamma B vertical times cosine omega 1t plus phi sigma x plus sine omega 1t plus phi sigma y. So how do I get this? Because the perpendicular times cosine is equal to bx, right? This is the bx component, x component. B perpendicular times sine equals to by, right? So that's why I just put this into here, h bar divided by 2 times this whole thing. Is that okay? A little bit confusing, right? But then we want to do two substitution, which we call it, sometimes call it Pauli raising operator or lowering operator. We don't need to know this now, but it is this. We set an operator sigma x plus I sigma y equal to sigma plus. Okay, sigma x minus I sigma y equal to sigma minus. Just a definition, right? Well, we can try a little bit, right, to understand, yeah. Plus, sorry, yeah. We can try a little bit. Let's say sigma x, sigma plus. What is this? Equal to sigma x 0, 1, 1, 0 plus I was y, negative I, right? I mean 0, right? Correct? This is sigma plus. I times I equal to negative 1, right? So this gives me 0, 2, 0, 0. Right? This is not a Hermitian matrix, not a unitary matrix. But this is a useful matrix called raising operator. And you might be able to see that if I start with a lower state, I can raise it to the higher state. Right? But let's don't worry about this, okay? So with this, right, and because gamma is less than 0, is negative, okay? So now I try to make gamma, know gamma is less than 0. Then with this, then I can plug in, I get, and actually before that, I need to show you what is sigma x then, because I need to do substitution. Sigma x equal to sigma plus sigma minus divided by 2. Do you see that? When I do sigma plus sigma minus, then these two terms cancel, right? I only have 2 sigma x. And similarly, sigma y equal to sigma plus minus sigma minus divided by 2i, right? Because sigma plus minus this 1, then sigma x got cancelled. I get 2i sigma y divided by 2i, I get this. Okay? And then I will substitute into the equation, hi. Right? First of all, I will call this one equals to h bar omega r. There's a reason I call it omega r, divided by 4. Where omega r, what is that? Maybe I'll do that later. And then this one is going to times the, where, actually maybe I should do it now. Where omega r, capital omega equal to gamma, the magnitude of the gamma times b perpendicular divided by, no, I did not divide by 2, just this one. This is omega r. This is a new rapid oscillating frequency, which we would look at more. what I do is just I substitute the gamma, beta, B perpendicular to be omega r. I take absolute value because gamma is 0, right? So this becomes positive, so I remove the positive, the negative sign also. Okay? So maybe I'll continue next time. It's already 46. Yeah, your question?
I think generator rotating magnetic field.
I think what you can do is you have two wires perpendicular, right? So you are generating each of them out of phase. I can think of this, but maybe I'm... Okay. Okay. Yeah, I don't know exactly how implement, but just two wire perpendicular. You can get two components. Okay. All right, good. Let's stop here. Although I'm slow, but I think we need to do this. Make sure if you have question, please let me know.